All right, welcome back. So this is an ALEKS topic that's called calculating the heat of reaction from molar reaction enthalpy and the mass of a reactant. So quite a mouthful there. And this is a really great introduction topic to the concept of thermochemical equations, which we're going to need for our study of thermodynamics. So this is sort of the first sort of introduction, and in this video I'm going to talk about two different examples. So this example here, and then one more example that's a little bit simpler. I think this one does a good job of giving us a good overview though. So in this problem, just sort of getting oriented, we just have to answer these few questions based off of our given thermochemical equation. So when I'm looking at this thermochemical equation, there's a few things that sort of jump out at me right away. And one is just sort of how to read this properly. What this is saying is that if you take 2 moles, so these coefficients here, they're very important when we're using our thermochemical equations. If you take 2 moles of NH3, and you decompose it into N2 and 3 equivalents of H2, that requires 160 kilojoules of energy. The fact that this is a positive enthalpy change, that's telling me that this is an endothermic reaction. So we can go ahead and answer our first question here. This delta H being positive means that for this reaction to occur, we actually need to put in 160 kilojoules of energy for every 2 moles of NH3. So that, these coefficients are related to this amount of energy. So this is an endothermic reaction, a positive delta H. Suppose 41.5 grams of NH3 reacts, so we're gonna have some, mass of NH3 that's gonna react. Will any heat be released or absorbed? Since it's endothermic, we're going to be absorbing energy to run this reaction. So now we need to answer this last question. I think this is sort of the hardest part of this problem. And it says, if we do this reaction with 41.5 grams, how much energy will need to be absorbed to run this reaction? So the first thing we're going to do is we're going to convert into moles. So 41.5 grams of NH3 times 1 mole over 17.04 grams equals 2.435 moles of NH3. So just a quick grams to moles conversion. And the reason that I want to do that is because these, coefficients and this enthalpy change, that's based off of the number of moles. It's 160 kilojoules for every 2 moles. So I'm going to use that as a conversion factor. And the way that that's going to look is 2.435 moles of NH3 times it requires positive 160 kilojoules for every 2 moles of NH3. So I'm using the information from the thermochemical equation as sort of a conversion factor, right? Every 2 moles of NH3 requires this amount of energy. So I can use that as a conversion factor down here to say, well, if I have 2.435 moles of NH3, how much energy is that going to require? My units of moles of NH3 should cancel, and I can end up with my final value here of 195 kilojoules. We're asked to answer in 3 sig figs, so this is the answer that I'm going to put in over here, 195 kilojoules. All right, let's do one more example. It's a little bit more straightforward. It's also an example of an exothermic reaction. So in this reaction, I've got a negative delta H. This is a pretty common combustion reaction. I've got methane. We're going to burn some methane in oxygen, form CO2 and water. And this is saying that 1 mole of methane, right? We have to keep in mind our coefficients here. 1 mole of methane, when I burn that in 2 moles of oxygen, I'm going to get these products. And that's going to give off, it's going to evolve 882 kilojoules of energy. So the negative delta H there, the negative enthalpy change, that's telling me that's an exothermic reaction. If I do react 59.1 grams of CH4, yes, we're going to be releasing that energy because it's an exothermic reaction. So now for this bottom part, figuring out how much energy is going to be released, again, we need to figure out how many moles and then use that sort of conversion factor that we were talking about earlier. So 59.1 grams of CH4 times 1 mole over 16.05 grams, just the molar mass of that methane, equals 3.68 moles of CH4. So this balanced thermochemical equation that's saying if you have 1 mole of CH4 and you burn it in oxygen, you're going to get this amount of energy. But we want to know how much energy is going to be released if I burned 3.68 moles. So again, I'm going to use this information as a conversion factor, 3.68 moles of CH4 times minus 882 kilojoules That's the amount of energy for every 1 mole of CH4. My units of moles of CH4 will cancel out, and I get a value of minus 3247.7 kilojoules. So this is saying that this is the amount of energy that will be evolved if I burned 3.68 moles of methane, right? That 59.1 grams. If you burn that, this is the amount of energy that's going to be evolved because it's exothermic. So in this problem, it's asking how much, it says, calculate how much heat will be released or absorbed. So we're actually going to ignore the negative sign. The negative sign is telling us it's exothermic. It's telling us that that energy is being released. But when we give our answer, we're just looking for an absolute value of energy. So I'm going to think of this as a positive value. And then it also asks for 3 significant digits. So the best way to enter our answer in this case would be a positive 3.25 times 10 to the third kilojoules, right? So that's going to be the answer that we're looking for. Rewriting this number, 1 is a positive, but then also as 3 sig figs, the easiest, best way to do that is just to write 3.25 times 10 to the third, because 3250, we're going to write that like that. Okay, hopefully that makes sense. Definitely comment below if anything doesn't make sense. Cheers.